Hello everyone, I'm excited to introduce our newest series. We're going to be looking into EV components for the Acura NSX. Now this part in front of us is called the battery control unit, also the inverter converter. And what we're going to do is we're going to do multiple videos. We're going to introduce the part, we're going to tell you what it does, and then after that we're going to look at individual components so you guys can learn about the EV systems and you can learn about individual parts and you could just become smarter and also look at the coolness behind this technology. All right, let's get started. So another common name for this is called the junction board and the DC-DC converter. Elise made a video called the deep dive into the EV systems, and we're going to go ahead and play the clip that talks about this part so we can introduce it to you and you can know how it functions within the EV system, and then we're going to go part by part.
The junction board contains a battery current sensor, which sends information about the current to the BCM. The DC-DC converter converts high voltage current into low voltage current to maintain the 12-volt battery's voltage.
So in this video, we're going to be looking at the basic parts first, and in the next video, we're going to be looking at the more intricate parts of this EV system. So let's go ahead and get started with teaching you about the color coding. Now, if you look at these orange wires, you're going to see these on most EV systems. And these usually mean they're high voltage, and they're designed to warn you that they're actually possibly dangerous and that they consist part of the actual high voltage system. So as you can see, we have these two right here, and then this one right here, and then one behind here. Now, I opened up this cover here to show you that this point right here is actually protected. If you look over here, there's some more protection points, and there's a lot of shielding. But if you look right here, this is really important because this is something that you see every day, but in an EV system, it's very critical. And this is going to prevent interference. The technical name is ferrite bead. I might be mispronouncing that, but it is protecting against radio interference, interference of electronics. And this is going to be important because whenever you have high voltage, depending on the oscillation and the frequency and everything involved with electronics, they decided that they needed to protect this from any type of interference. So we have another ferrite bead right here, 1, 2, and 3 of these so far. Now, when it comes to high voltage wires, you're going to see that they're going to be thicker. Now, this is pretty thick, and when you're talking about the thickness of a wire, it's typically the wire gauge. And it's interesting though, because as the number is smaller, the wire is actually bigger, and as the wire gauge number is larger, the wire is usually smaller. It's kind of inverted, which is funny. Now, if you look right here, we have some really thick gauge, and it's actually really well insulated. Now, when we disconnect this connector right here, we're going to be able to see that inside here, there's actually the male ends. Now, what you see here is actually called the junction box. And if you look right here, these are junctions, and we're going to show you how they're actually interconnected and separated. I also want to tell you guys that when you have certain components that are designed like this, they're like roads. Certain parts are closed off and certain parts are not. Now, I have my multimeter set on continuity. That means when something's connected, we'll hear it. So when I put my negative lead right here and my positive lead right here, we're going to hear that because this is connected, right? And then we're going to go all the way here. That's connected. Then we're going to come around here and it is not connected. So somewhere around here, this stops being connected. This stops being connected. So we know that this portion right here is connected all the way around here, and it stops right there. Now, when we switch to our positive lead right here and then our negative lead right here, we have connection. We also have connection there, so we know this ports right here are connected. So we can already tell that this side right here is isolated, this side right here is isolated, and it looks like when we disconnect this, we're going to see this. So the left pin on this one is connecting to this circuit board, and then the right pin on this one is being connected to this board. So this connector right here is literally using both halves of this, but they're not connected. Now, what we're seeing is an exposed section of this unit, meaning that there's a cover that goes over this. It didn't come with this unit when I purchased it, but I do want to mention something that within the cover, we're having wires that are shielded. We're having multiple parts that are covered within the cover, which is a good separation of high voltage stuff. Now, when it comes to EV systems, You have to be very safe. This particular control unit does not have any batteries. This is inert, meaning that we can look at stuff. Here, we're just showing you, we're not teaching you how to disassemble or work on an EV system. We're introducing to you the technology, components, and helping you learn. So as you can see, this component right here is going to be in our next video, but I'm just trying to show you guys the hardware and what is working within this area. But if you look right here, guys, below it is plastic, right? Where this is going to be contacting this, which completes the circuit within this unit. Now, if you look at this connector right here, look at the size and gauge of these wires. They're very small compared to our orange encased wires. Typically, these are going to be signal wires. And the way that signal wires work is they usually don't have to be big. They're usually just working with 5 volts. Now, you need to cool this unit. Most EV components need to be cooled either by air or by coolant. And in this situation, we're going to be talking about air. If you look at this air duct goes in here, the air goes in here, and then it comes out through here. But if you look inside here, we actually have some fins that the air goes through, which is actually cooling down the converter. So in this situation, it's using air, but the NSX also uses coolant to cool some EV components.
The intake for the air is behind the HVAC unit. The BCM calls for air from the cabin or HVAC unit, which allows air to pass through the battery pack and the heat sink of the DC-DC converter, from which it is discharged outside of the vehicle.
And this is one of the air vents, and this allows the air to be circulated in the EV component system. And it looks like your typical AC vent, but it's also insulated, which is pretty cool to prevent it from losing some heat. And it's made out of rubber and plastic, but it's going to be really important to get that heat out of that EV system.
If the DC-DC converter becomes too warm, the BCM will disable it, and the 12-volt charging system indicator will illuminate.
So in this unit, there's some conversion going on. And whenever you're converting electricity or within electronics, you're either upping the power or you're downing the power or you're converting the voltage type from AC to DC. Now this is a DC to DC converter.
The DC-DC converter converts high voltage current into low voltage current to maintain the 12-volt battery's voltage.
And in our next videos, we're going to talk about what these Panasonic components are, this copper one or copper cased one, and these really funky looking ones that we see right here that look like fuses. We're going to go deeper into this system, and it's going to be great. Well guys, I hope you learned something. This is a ton of fun, and in the next video, we're going to go more in depth in the different components, so make sure you stay tuned. Hit that like button for us because we bought this unit so we could share it with you guys so you guys can learn more about the NSX EV system. Thank you for watching, take care, and we will see you soon.